of the formula that takes a little while, and it requires patience and accuracy when you're working with the quotient rule. Now going back to our function, all we need to do is to find now the derivative of 2x plus 1, which is 2, and the derivative of x minus 3, which is 1. And by doing so, we'll be able to complete our derivative function for f of x, giving us x minus 3 times 2 minus 2x plus 1 times 1 all over x minus 3 squared. Now, this particular function right here of f prime of x is already the derivative of f of x. Now, if we want to further simplify this function, usually we can simplify the numerator. Just like here, we can distribute 2 to x minus 3 and distribute 1 to 2x plus 1 and then subtract them afterwards, giving us f prime of x is equal to 2x minus 6 minus 2x plus 1 all over the square of x minus 3. And by further simplifying it, we can eliminate 2x and combine negative 6 and 1 by subtraction, giving us negative 7 all over x minus 3 squared. So that's how we use the quotient rule in finding the derivative of your rational function. Now for problem number 2, we have another rational function, which is 3 all over x cubed. Now I'm going to introduce you another strategy in finding the derivative of a rational function. Sometimes you don't need to use this formula in finding the derivative of a rational function. Similar to this one, since your denominator is just one term, every time you have a one-term denominator, what you can do is just change your denominator into a negative exponent, giving you 3 times x to the negative 3. And by changing your f of x into this kind of function, makes it a lot easier for you to derive this function using the power rule. And the power rule, we can just find the derivative of x to the negative 3, which gives us negative 3 times x to the negative 4. Multiply 3 and negative 3 will give us negative 9, x to the negative 4. And if you want to get rid of the negative exponent, your f prime of x will look like negative 9 all over x to the 4th. So once again, if you have a one-term denominator in a rational function, you can use this approach in finding the derivative of the rational function. And if you have a two-term or more denominator in your rational function, I would suggest that you use your quotient rule. Now for my third example, I have 2x cubed plus pi x all over 3x minus 7. Now we're going to use the quotient rule right here because you'll notice that my denominator is a two-term denominator. So we'll use low d high minus high d low all over low low. So we have low derivative of high minus high derivative of low all over the square of the denominator. Now we're going to find the derivative of 2x cubed plus pi x, which gives us 6x squared plus pi. And we're going to find the derivative of 3x minus 7, which gives us 3. And by simplifying our derivative function and replacing our ddx with this function right here, now we have a binomial 3x minus 7 times 6x squared plus pi minus 2x cubed plus pi x times the derivative of 3x minus 7, which is 3, all over the square of 3x minus 7. Now if you want to further simplify this, what you can do is you can FOIL your first term here in your numerator, distribute 3 to your 2x cubed plus pi x, and then subtract them afterwards. But in this case, what I just did is I leave my first term like this, like a binomial, minus 6x cubed plus 3 pi x all over the square of 3x minus 7. So once again, this particular equation is already the derivative of your function, so this one is already acceptable. And if you want to further simplify it, you can make the numerator smaller by foiling and canceling like terms or combining like terms in the process. And this is how we use the quotient rule in finding the derivative of a rational function.